Hello everyone. In this video, I will give you the latest update about the hand tool project for the manufacturing engineering subject. Now, unfortunately, after all the efforts we try to make to make you actually do the work by hand, um, it actually has been smashed by the lockdown. We cannot do go further regarding the sending the kits to you, so you can do the work at home. Accordingly, we had a meeting last week and we decided to actually change the way that we're going to run the project this semester. And instead of making the handwork, we're going to make the things more theoretically for you. Again, we're going to work in a groups of four, as the one we actually had registered to earlier. You can find the groups available for you here. If you hadn't joined the groups yet, you go to people on Canvas and enroll yourself into the hand tool project groups. You're only going to bring the Excel sheet you signed in into the teams and join the groups here. Now, the group is going to be consist of three students at maximum. Minimums can be individual team individual work. Uh, the points we're going to cover in this project this time is going to be mainly focusing on the following points you're going to write down on the paper. So first, the competition is going to be about making the design. First, the design. So three students, I expect to find three designs. Doesn't matter how the similarity is going to be. The design mainly is going to be focusing about, for example, the diameter of the tube, the shape of the valve, and for example, the arrangement of the valves. That's example. Okay, so every student is going to work with different design, and when I say design, you don't have to do, for example, the finite element analysis for their design. It's only going to be making the hand sketching for that. I'll give you a very simple example here. This can be design number one. It's just the normal pump we have, okay, and for example, at the end, we're going to have an extension. Okay, so this can be the first design. Okay. The other design is we making the arrangement of the multiple valves. So we're going to have multiple chambers. This will be the piston. Sorry, the rod. We can have the valve here. We can have another valve here. So what we're going to do is the 100 millimeter stroke is actually going to filled in multiple stages. And in that case, we're going to have level one, level two, and the stroke uh, chamber. And here we're going to have the foot valve. So multiple, and this will help you actually to take the water to a higher level. Another example can be the same diameter pipe, but to increase the flow rate, we can have the multiple barrels. So for example, this can be twin. So we're going to have two rods, okay, going up and down. This will go down while the other one will go up. How to do that? Simply, you can have an arrangement here, which work as a cam. So it can work like that. So this one is going to be moved from one direction. This stroke going up and down is going to push the other one the other way. So now I just give you an idea of three different designs, and you can actually work on different even more. One of the example is for the valve itself. This can be the valve I showed you earlier in the drawings is going to be just a disc with the multiple holes. More holes and larger holes, of course, going to make a better flow. We can have the valve which is going to look like a flipper. So, for example, the foot valve, instead of being something like that with the seal at the top, which is going to be the washer, we can have it as a flipper shape. So it's going to look like that, and it's going to have a door. Okay, circle door, and we're going to have a hinge here. So as we're going to pull the thing, the water will push the flipper out, and when we are going to push, it's going to send it down. That can be another example for the foot valve. Further example we can have let me think about, oh yeah, so for the lower valve, instead of have it like a flip, we can use the ball valve. The ball valve, we're going to have the 3D printed base. Okay, this can be a disc shape. Okay, and it's going to have this shape. So the water will come from here, and we can use a ball. Okay, plastic ball. Mainly it's going to be plastic because the plastic is going to be floating. Uh, well, it's going to work. Yeah. So what's happening is that when I'm going to pull the thing, the ball will go up and let the water pass. And when I'm going to push, the ball will go down and close the passage and prevent the water from coming. So design is going to be task number one. Task number two is going to be the calculation. It's not going to be a very complicated calculations for the student. We're going to talk about this one with you later. For example, you can calculate the water flow rate, and this will depend on the number of strokes we're going to have and the velocity. Then you can calculate basically how much water will be passed through the base valve and how much water is going to be passing to the top. Actually, you can do some basic calculation for the height you can send the water to. At the end of the uh, week number 10, I think, you are going to have a presentation. So every group is going to have something about 6 minute presentation where the three students are going to talk about their different designs and why they nominated one of the design to be the minor. Okay, it's not going to be hard. We're not going to have a questions session. You're only going to present your works and you will explain why one of them, according to your peer review, was better than the other. Number four is going to be applying the DFX, which is design for X. Where you're going to, for example, do the design for the manufacturing, discussing the different manufacturing processes, which one is going to be the easiest one, which one is going to be the complicated, which one is going to be the costly one, and which one is going to be the lower cost one. Okay, and you're going to do, for example, calculation for the assembly, calculation for the assembly, and other stuff. So you are going to base your calculation for the cost and the manufacturing as you're making 1,000 pumps. Point number five. Well, actually, we talked about that. It's like doing the different design and different arrangement. Um, the challenge is using the CAD software to create the CAD models. and engineering drawings. Okay, engineering drawings. Generation or bill of material. BOM. The bill of material. When you're going to make a pump, um, as an assembly in the SolidWorks, you can generate the bill of the material directly. And I'm going to show you how to do that later. So that's what we need to do. And as I told you that things are not going to be too hard. We're going to show you actually how to generate. I'm going to show you how to do every step. We're going to show you how to do that during the session we're going to run in week number 5 and 6. And also, I'm going to make a video on how to use your CAD model earlier. Maybe it's going to be run this week. Tomorrow, I'm going to post, tomorrow or the day after, I'm going to post the video for the minor project first. And then we're going to go during this week to talk about the hand tool project. So I'll put the photo of these 6 points, okay, designs. We're going to have to show the different valve arrangement and the shapes, different arrangement for the pump diameters, pump number of the barrels, and different foot valve shape, and the calculation for the flow rate and calculation for the head. Okay, I will mention that here. Flow rate and uh, head. Well, what I mean by the hand is how high the water is going to be pumped to. Efficiency, of course, efficiency is going to be here. Prepare yourself for the presentation. Present the design for X per 1000 pound. The design for X is, again, to talk about this one here. The CAD software to do the CAD models and the engineering drawings for every design. Generating the bill of materials for the assembly. Now, for the DFX, if you just uh, confused with this one, I think you did that one already anyway, is going to be design for manufacturing. It's about how to use the best operation to make the parts, and also how to use the available machines you have, because that's something we're going to talk about later multiple time. If you have the milling machine, you can use it. If you don't have milling machine, you don't have to buy a milling machine for one job only. Okay, so that's designed for the manufacturing. How to make manufacturing easier, simpler, and less cost. Designed for manufacturing. So use what you have already. Use simple machining process or processes, and use less energy in processes. Okay, of course, that's mean the simpler process is going to be the lower cost. Um, Design for assembly. Okay, that's mean less time to assemble the product. This mainly will come by using less parts. Design for in the assembly, because at the end of the life cycle, You need to deassemble the thing. Okay, it's about matter of time. How much time? Less time. Okay, because you know that the time mean more labor cost, and thus you are going to pay more for the same product. And finally, design for recycling. Because you know that recycling is one of the most important aspects we have in manufacturing today. We always have to think about, okay, now after 1 year, 2 years, 10 years, this product is going to be out of service, and we need to use a material that's going to be much easier to be classified as recycled material. For example, the aluminum I can recycle multiple times. The plastic is going to be much harder. The 3D printing material, we still don't have any idea about it till this moment. The bolts and nuts, maybe we can reuse them. Many of the parts can be reused. For example, uh, the hand pump we used to use earlier, we were using the old pipes to be recolored again to make a new design. Okay, and for the shaft, the same thing, or recycle the shaft. For the T junction, we will actually just use them again because we don't have to throw them. Okay, so I will pass the paper slowly, and I'm going to scan this one and send it to you. Okay, so this will be the recent updates for the hand tool project for this semester. I will give you more updates as we go with the semester, and I hope that we're going to make this semester as successful as we can. Thank you very much for your listening, and I hope to see